Let's try this again. All right. Now, in most cases, as we saw before, we can simply use direct substitution, as we saw here in the first part of the video. Now, in some cases, direct substitution doesn't always work because if you try to plug in the number directly, like you see here, you get 3 minus 3 over 3 squared minus 9, which ends up giving you 0 over 0. So in this case, it's not going to work. But if you apply some algebra here, and you'll see you give x minus 3 over x plus 3, x minus 3. Well, the x minus 3 will cancel, and you're left with 1 over x plus 3. Well, when you plug in 3 for x, you get 1 over 6, which is, well, 1/6. That equal sign is not supposed to be there, so I'll just get rid of it. I'm still trying to learn how to use this ViewSonic board, so I apologize for any technical difficulties. Okay, so sometimes you have to simplify the expression before or the function before you can start plugging in. All right, now let's look at the following. Another method is to actually use the graph. So you're going to notice a few things here, and let's go ahead and take a look at this. All right. If you look at this on your notes, you'll know that the limit as x approaches -1 from both the left and the right, it's going to approach the value of 4. Well, when I plug in -1 for x, I'm also going to get 4. So both of those are equal. Now, when I'm talking about when x equals 4, let's look at x equals 4. X equals 4 is right there. I'm going to show that in green. So right there in green. But if you look, there's a little hole there. So the limit from both the left and the right approaches 2. But if you look, the function actually equals 5. So these two are different. So that means it's not the same. That is an example of a hole. Now if we go to -4, if you look here, from the left side, it approaches 3. From the right side, it approaches -2. That's what's called a break. Since that's a break, that means that the limit does not exist. But if you look at -4, the function has a value of +3. So they are different values. Here is an example of a break. And this right here is an example of a hole. All right. Now you can pause this anytime. If you have any questions, you can shoot me an email, and hopefully that will help you a little bit. All right. Now, before we got here, just got some basic. We got to determine whether or not substitution works, the graphing method, or whether some other method like the numeric direct method works. All right. Now here we can just plug it in. So I got -2. -2 squared minus 3x, which actually, and remember, x is -2, and then plus 1. And if you solve that, that's going to give you a value of 11, equals 11. All right. Now for number 2, if you plug it in, you're going to end up with 0 over 0, so can't have that. So we got to simplify that, and we got radical x minus 3 over radical x plus 3. And those will cancel. And actually, hold on, let me fix that. Sometimes I get a little bit ahead of myself and start writing a little too rapidly, so I apologize, radical x minus 3. And that's going to leave us with radical x plus 3. Well, when you plug in the value of 9, so radical 9 plus 3 is just going to be 6. So the limit is 6. You have to use some algebra in order to solve that. And let's look at the third one. Now, obviously, from looking at that, you're going to have to use the graphing method. So here's how it works. If you've never graphed an absolute value before, here's how it works. Go to y equals, hit the math button. Now you see math, num, CPX, and PRB. I think probability is one of them. I don't know what CPX means. Y'all probably know more about graphing calculators than I do. I'll be straight up with you. But let's go ahead and click over to num, and then you see ABS, that's absolute value. So in there, you'll type X, and then below that, hit divide X. And then when you hit the graph, here's what happens. The function looks like this. At 1, and that's at -1. It's an open dot there, but it's a closed dot here. So the graph proves one thing. From the left, it gives us -1, and from the right, it gives us +1. So therefore, the limit does not exist. All right. That you have to use the graphing method for. All right. Now, we've talked about when limits exist. Let's talk about when limits don't exist. Now, here's what you need to know for that. To prove the non-existence of a limit, here they are. The function approaches a different number from the left side than the right. The function increases or decreases without bound. Now, an example of that is an asymptote. So, if you want to see what that looks like, here we go. That's just the basic function. But let's say that is the asymptote right there, and it kind of does that. So I'll just write down the word asymptote. And the third one, a function oscillates between two fixed values at approaches. Basically, it just keeps going up and down and up and down. All right, so the big word here is oscillate. Now, here's what I want you to do. To show an example of this, I'm going to let you do this one on your own, but I'll show you what to do. So, this one actually, well, it'll be the second one. I had to look at that again. I apologize. All right. If you type in 1 over x minus 2, here's what you're going to get. You're going to get an asymptote here at x equals 2. And then it's going to do this. It's going to do that. Now, it's not a great graph, but this is when it increases, or decreases. Without bound. All right. Now, for the next one, I'll let you do this one on your own as well. Consider the graph of consider the graph of sine of 1 over x. Now, what you'll want to do is you want to follow the parameters here on it. And all you do for x min and x max is type in native pi and pi. And then for x scale, it's pi over 2. It'll go ahead and do that. So type in those parameters on your graph. Then And of course, type in the function y equals 1, sine of 1 over x. Just type in that, and you're going to notice it does something real funky. It just kind of oscillates. It kind of just, you'll notice it kind of oscillates. And then keep the function, type in these numbers. You'll see the same thing. And type in those numbers again, and you'll see the same thing. But that's an example of an oscillation. All right. Okay. So those are some examples of what you can do on your own. Experiment with it, play with the calculator, get some experience with it on your own, because you'll need to see more of that as time goes on. All right, now here's what you need to do. You can either do this on a piece of paper or you can do this on a Google Doc, however you want to do it. But go ahead and work on page 72, these particular problems right here. If you need questions on them, you can always look on www.calcchat.com. That site is linked on the first module for the semester for the introduction. It'll give you some help on the odd problems. And then you can do one or two things. You could post it on a Google Doc and share it with me, or you can take a picture of it and email it to me, however you want to do it. But you'll have until Friday at 11:59 to get it turned into me. So email me if you have any questions, and I'll get back to you as soon as possible.